I would like to first of all very welcome you to this kind of events, this kind of series where we want to talk about geomorphometry. You might have received this kind of information via different channels, and that's the reason why I will make a little bit 5-minute commercial for our society about geomorphometry, which is a science of quantitative land surface analysis. It combines a range of topics, people from around the world, and you can find us at geomorphometry.org. We are a non-governmental, non-commercial association of research and experts that are open for the free exchange of knowledge, opinions of various aspects of dam processing. We would like to improve the understanding of land surface, how we can model it, how we can model the elevation, what can we derive from that one. And we want to talk about dams, about techniques. We want to foster collaboration. What can we do? How can we do that even in an international context or a national context or a regional context? And we want to be inclusive across all the world, across all kinds of societies, students, researchers, if you are up at the end of the career or you just starting to work with that one. We have a biannual conferences, which is planned for next year, and the announcement goes out shortly on that one. So we're looking forward to your proposals for that one. Here with the coffee talks now, we would to facilitate a little bit of exchange between our biannual conferences. We want to train, present, outline topics, really give you all a platform to discuss geomorphometric topics with the community. We have designed this coffee talks to be really limited within 60 minutes. We assume that we will, well, this is our idea, and we will see how this works out, because this is today the first one with Laurence here. We will have 15 to 20 minutes presentation. Afterwards, open discussion, respect your peers, be nice. And at the end of the session, and we try to stick to the 60 minutes, we will have a short session wrap up. What have we learned? And as this is a virtual event, please promote it locally. You can follow us on Twitter. You can follow us on LinkedIn. You can come to our geomorphometry conferences as well to follow up at sessions at EGU or AGU, which are organized from the community. With that one, I hope from the almost 60 people who have registered, which Vincent already showed up earlier on, I would like to introduce you today, Laurence. Sure, if I mispronounce your name.
Yeah, Laurence. That's good.
Thank you. He's a senior research associate from the University of Bristol, and he's specializing on global flood models and DMs, and he works currently in the project of EvoFlood. And I thought his title was really dominant and really pregnant, putting it down, and we're all curious to learn about FABDEM and what we can do that one, what not, and where you suggest to use it or not. And please, the floor is yours. I will stop screen sharing here and hand it over to you. And over to you. And I will shut up. And I will moderate it afterwards. Thanks.
Great, thank you. Can you see my presentation? Thumbs up. Smashing.
Yes.
All right. Well, thank you very much. Yeah, it's a real honour to be the test case for this. I guess the coffee breaks. So Yeah, I'll be talking about FABDEM today. I'll be presenting on behalf of the FABDEM team. I'd especially like to give a shout out to Dr. Peter Uwe from FABDEM, who gets quite often overlooked because he's the second name on the paper, but has done a huge amount of work to FABDEM. Right, so the general, there we go. The general outline of this talk is what is FABDEM, if you don't kind of know about it. Latest FABDEM update. So this is kind of hot off the press, really. Not been formally published. So kind of basically how we're fixing things that are not working so well. And then, as Hans kind of mentioned, I'm from the global flood modeling world. So if we do get onto that, it'd be kind of how it's been used in global flood applications. Yeah, I'd encourage you to kind of ask questions. I really want to hear where people are using FABDEM, where it's working well, where it's not working well, suggestions to how to improve it. Yeah, just kind of be frank and honest, really. Is all good, because this is definitely an evolving product. Right, so well, this community, I don't really need to go over what is the difference between a DSM and a DTM. So let's swiftly move on from that. So essentially, the big problem that we have in our field is no global digital terrain model. So back in 2018, I estimated rather optimistically that about 0.005% of the world's land area was covered with high quality LiDAR. I would say there's quite a lot more now, but the headline is an absolutely minuscule amount of the world's surface does not have digital terrain models. And then mostly we're lacking in developing countries or countries that are really most vulnerable to increase in hazards and climate change effects. So there's a huge need in the community for a global digital terrain model to fill these gaps. To date, probably the closest DEM to a DTM is the Merit DEM. So this was released by Diane Yamazaki back in 2017 or whenever it was, and this was a major correction of SRTM, which removed forests, but buildings were not removed. A really nice product, but a key event happened several years ago, and this was the release of the Copernicus Glow 30 DEM. So I've kind of provocatively put here the end of SRTM question mark. So a bit of context here. So as Hans said, working flood modeling. So I was working on a project in Vietnam, and we were looking at the TandemX 12-meter data. The idea was to create a flood model from this, but we quickly learned that it was a very noisy data set, and we're kind of looking to remove these trees and building artifacts. I was kind of developing an approach for that, but kind of thinking, okay, is this going to be really that useful? Because we need to get permission to use it, and it's not the easiest product to use. And all of a sudden, Copernicus Glow 30 was released, and we kind of did some comparisons and found it to be favorable to other global DMs. There's a really nice quote here from Peter Goof, who I think is on this call, calling it the gold standard, or what should become the gold standard of DEMs. So now I think finally we've got to a stage that we can move on from SRTM and have a new kind of best baseline DEM to do our corrections to make a DTM. So really it's kind of an opportunity knocks, really. We thought, okay, let's use this opportunity to create a product that we remove trees and buildings from the Copernicus Glow 30 DEM, and kind of use a few image filters to remove the erroneous noise. Still now I'm a postdoc on a short-term contract, so kind of getting these things out quickly and but doing a good job and getting something that can be really useful in the community is crucial. So yeah, that's kind of why it was a very quick process, really. Right, so I'm going to go quickly over the workflow, but I don't want to get too bogged down in this. So essentially, I looked at a bunch of different machine learning methods and settled on random forest. I didn't look too much into CNNs, which maybe was a mistake, and someone might get a question about that later, but I'll come on to why we might be looking into that in the future. So essentially what we need in machine learning is to have data sets that are going to predict the patterns or the errors in what we might see in the Copernicus DEM. So what we need is some data to predict the forest height errors and from the buildings. But we have to remember we need global data sets first of all, and we need data sets that, and these data sets are not perfect. So for instance, there's a forest height product that we use based on JEDI, which is brilliant, but it's not perfect. So yeah, we use a bunch of kind of the latest data that we had at the time, and also created a bunch of different filtered images. So this is kind of to create perturbations of what the forest heights might be, for instance. Yeah, so we used, I think it was 15 different predictors for forest height and 14 different ones for urban areas or buildings as such. We also needed reference data sets. So we got this from LiDAR, and we used it from 12 different countries. Now, the key thing here was to get a wide range of urban landscapes and climatic zones. Like it's no good training a global model on LiDAR from Bristol, for instance. Like that's just not gonna. Bristol is not the same as Hong Kong or Detroit or whatever other urban area. So we really tried to get some LiDAR from Africa and a bunch of other areas, but we were very careful to be confident that we were doing the vertical data transformations correctly, because ultimately if you throw rubbish into a machine learning model, you're going to get poor results. So yeah, we're really quite cautious with that, and perhaps we could have used some more LiDAR, and perhaps we will in the future. Second stage was to do the forest and urban correction. So we separated this out. So from these schematics here, the solid lines are, the dotted lines are the original Copernicus heights, and the solid lines are kind of the corrected surface. So we did this separately, and then stage 3, we took the minimum value to create a new surface. And then we basically post-process this by applying a load of different image filters. So we had the adaptive filter, which is quite often used, bilateral, median, and just ran a bunch of different filters over this. Now, the key thing to remember here is we needed kind of a balancing act with keeping the features that you get in a 30-meter DEM and not completely smoothing it out like Merit DEM might do. But also, we want to get rid of the erroneous noise. And because we come from a flood modeling background, we really focused on these sort of areas, the flat floodplains. So perhaps the post-processing that we use is not ideal for a lot of locations. And I think that's quite important to remember. I'm quite keen to learn where people might have better ideas what we could do there. Yeah, so a few images of what it kind of looks like. So in the top right-hand panel here, we have Paris from the Copernicus Glow DEM and FABDEM. Arguably, Copernicus kind of looks nicer because you get those rough features, but for a flood model, we need this, the FABDEM sort of approaches. So comparisons against LiDAR, which shows, good results, but notice we haven't got down to 0. It's not perfect. So to go back to the title of the presentation, it's how fab is FABDEM. It's reasonably okay, but it's certainly not the answer. And similarly with trees, this is actually a really nice example in Germany. So we can see in the top image here a river kind of running through from east to west, and we can see some yellow points all along the river. So this is vegetation basically, and this is a disaster for flood models because it blocks the flooding. However, in FABDEM, in the image below, these are largely removed. So the model floods to an extent that happens in real life. Again, the comparison with LiDAR, we see some decent reduction in error, but again, not perfect. Let's have a quick drink first. So here we have got some images to compare to other DEMs. So yeah, we compared to Merit here and then LiDAR on the right. So of course, some improvement over Merit with the resolution improvement. So, but essentially you can see FABDEM picks up a lot more of the features in this kind of floodplain landscape here, which is important for the background that I come from. Similar sort of example in the US here. And there's another one in the paper from the Mekong Delta, which always gets used for these sort of comparisons. So we can see here FABDEM has a good reduction and removal of artifacts from the Copernicus DSM. It looks quite similar to Merit actually, but you kind of a few more details around the urban areas. So around like Kang Tao, for those of you know the area, that's kind of removed quite nicely. And NASA DEM is not great for this area. So yeah, we'll move on. So what makes FABDEM unique? So it's the first global DM to remove both forest and building artifacts. It has complete global coverage. When I say that, bit of an asterisk there. Not quite, but almost true. First terrain map of 30 meters, and we use a wide range of reference data. Yeah, the more details, it's a big old data set, 460 odd gigabytes in 1 by 1 degree tiles, and it's about 19,000 tiles we have in total. Now, accessing FABDEM is one of the banes of my life since we released this. So we had to, going through the university, we had to release it on their data portal, which basically is not designed to release large data sets. So yeah, if you have been trying to download it from basically outside of Europe, it's very, very slow, and I can only apologize for that. They have set up a BitTorrent, which has made it faster, and it is available on Google Earth Engine as well. We are working to resolve the situation. So yeah, I'm sure I might get a question about that. Yeah, it's far from ideal. It is, unfortunately, if you want non-research applications, if you want to make a bit of money out of an application using FABDEM, you need to go via Fathom to get a license. I'm not so involved in that, and yeah, I don't kind of know the pricing structure and all that sort of stuff, but that's just kind of a flag that people should be aware of. So limitations does not include Armenia and Azerbaijan. The reason for that is because it's not in the original Copernicus DSM or DM, sorry. Yeah, perhaps we can learn in the future, we can make it into some sort of merged product with perhaps ALOS or some other DM. A big question mark for me is whether the post-processing is suitable for all landscapes. I don't think so. And there's currently no watermask or compatible hydrography. Were released with FABDEM, so that kind of reduces its usefulness. We are working on these ones. Groups I know of are working on this, but yeah, that's kind of a limitations I can think off the top of my head. Right, how am I doing for time? Reasonable. So I'll go on to latest developments.
Go ahead.
Cool. Right. So this is so yeah, we developed the product in about 9 months, and we thought, okay, we did quite a bit of testing, but we thought, okay, let's just get out there and then see what the community thinks, and yeah, kind of let them test and break it essentially. So a group in Brazil came back noticing that there were some weird issues in the Amazon. So basically, in tiles that were almost completely forested, what happened is we were getting some weird buffering, weird artifacts where we were using the uncorrected buffer, uncorrected DEM for the buffer, and this buffer was also not that big either. So what this meant is when we were filling the depressions in one of the post-processing parts, it was basically filling in these valleys because it was taking the higher elevations from the Copernicus DM. So that meant we created FABDEM version 1.1-1. So this version actually never got released, and I'll go into why in a minute. So what we did to correct this was pretty simple, really. We it's not moving. Here we go. So we just used the corrected DM as a buffer, and we extended this buffer size as well. I think it was 10 pixels, and it went up to 0.1 of a degree instead. So this kind of fixed these issues quite nicely. So this image, you can really see kind of the boundaries between the tiles, which are obviously not good at all. But this was fixed in 1.1. So that was all well and good. So we were just about to release that, and then another group were kind of noticing in the higher latitudes some kind of weird striping in some tiles, particularly at the boundaries between 49 and 50, 59 and 60, and so on degrees. So basically, this is a result of how it was slightly shifted and the bicubic resampling that we did, and the way we kind of stored the data created some striping artifacts. So we fixed that, and then we thought, okay, whilst we're at it, we might as well update the latest Copernicus DM. So we used the 2001_2 version of Copernicus DEM, and then we've updated to no, sorry, that's incorrect. It's the 2020_2, and now we're using the 2021_1 version. And the map you see on your screen now is the tiles that have been updated and kind of corrected in this latest version of the Copernicus DEM. So essentially, we've just rerun FABDEM with these corrections and with this kind of new improved Copernicus DEM as a baseline. So it mostly makes very, very little difference in tiles. But some tiles, like this one, was a complete disaster in the original one. You can see this striping down the left-hand side here, and then it's basically a shift as you got to this kind of boundary sort of layer. Interestingly, with this tile, the one to the east of it was completely fine, but this one wasn't. So yeah, it's quite inconsistent behavior. So yeah, what we're currently doing now is so version 1-1 was not publicly released because we don't want to be putting out loads of different versions because that's a nightmare for users and for us. So we're on to 1.2 or 1-2 now, and yeah, I'm really checking this quite extensively now. So hopefully we'll have public release October 20 or this month, maybe early next month. We'll kind of see how that goes. And then yeah, kind of plans on the horizon. Next year we want to release FABDEM 2. So this will be basically updating the machine learning approaches, updating the predictor data sets. Loads of different products are coming out all the time. And kind of trying to keep the brand alive, really. Yeah, and that is kind of it for FABDEM. I have forgotten this actually. This is quite important. So this is a new hydrography data set, which is in preparation by a colleague at University of Oxford, who's part of this EvoFlood project that I'm working on currently. So this is a FABDEM-based hydrography essentially. And the really neat thing is it includes bifurcations, which is kind of the real golden bullet for hydrography data sets. So that's currently in prep, kind of going over some QCing of that at the moment. So hopefully you'll see that probably early next year, I'd imagine. Yeah, Han, shall I go over some flood applications, or should we kind of open it to the floor? Then, yeah, if we have time, go to that.
Laurence, I would suggest we finish up the presentation part.
Sure.
And we finish up the flood applications, and then we open up the floor. So for your information, you are at 20 minutes for the moment.
Okay. Well, I'll just go over. Maybe I'll just go over this one map here. So at Bristol, we have a global flood model, and it's based on this flood FP code, and then it has FABDEM is basically a spin-off company from that. So 3 maps I'm going to show here is essentially the difference between version 1 of the model that uses SRTM, which is uncorrected and still had the building artifacts. So this is currently what you see at the moment for a city in Vietnam. Version 2 of the model, this is using Merit DM. So as it removes the artifacts, it floods, well, actually floods as well. And then version 3 using FABDEM, you can really kind of see the floodplain features picked up a lot more. This is partly down to resolution, of course, so it's not perhaps a fair comparison. But this is the sort of applications that I'm working on. So this is all of it on one screen here. Yeah, so I think that's probably enough for that. I've got basically the same thing, but for different locations, and I think it'll be a better use of time to have kind of a bit more of a discussion. Then if people do want to see this, they can do a bit later. Okay.
Okay, thanks, Laurent. Really interesting presentation. Thank you very much. I'm opening up the floor for everybody to ask questions. Please raise your hand, put something in the chat, and we will give you the floor to ask questions. I don't know who wants to come first in from all the attendees. And I will not put, I have my own questions, but I will put them at the end. Giuseppe, up to you.
Okay, thanks. Nice to meet you, Laurence. I'm Giuseppe Matulli from Yale University. And
Hi,
I'm curious to know some information about the JEDI product that you use, and also how you treat the different JEDI power beam and coverage beam for the laser impulse.
So it was is the, what's it called? It's called the Global Forest Height Map by Popatov. And they kind of use like the early versions of JEDI to create a forest height mask. Now I think that's been yes, which I know has some issues. And we did find it to be okay, but it certainly did have its problems. There has been a group, I think Nicholas Lang, I think his name is, has kind of created another version based on new JEDI products, and probably someone else. I've not really been keeping in touch with the literature the last few months. So yeah, that's we kind of use an off the shelf sort of process on. We didn't actually do any processing of JEDI itself. Does that kind of answer your question?
Yes, it's clear. Yeah. Okay.
Smashing. Thank you.
Okay.
Yeah. Next. Just to keep in mind that the JEDI, just to give you some suggestion on the JEDI processing, there are different products. There is always in the laser beam, there is always the coverage beam and power beam laser impulse that has different standard error for the tree height. So that one can be also influencing later on the final digital surface model.
Okay, thank you.
Terrain model, sorry, terrain model. Yes, surface and terrain.
Great, thank you. I'll just write that down.
Okay, that's it from my side.
Thank you.
Thanks, Giuseppe, for the question. Thanks for the answer. And who wants to have the floor next? Any questions from the audience? I see. Nice to see many known faces, and also nice to see some new faces here. Not a question, but I mean, sorry, Mike McFerrin. you are showing up. Please, floor is yours.
Yes. Hello. Can you hear me?
Yes, maybe.
Okay. Yes, great. Hello. My name is Mike McFerrin. I am a new member of this community, but you'll be happy, I think, to know Laurence at NOAA, National Oceanic and Atmospheric Administration in the U.S., and NCEI, the National Centers for Environmental Information, where I work. We are using FABDEM, at least version 1, as the base layer in our new global topo-bathy DEM layers. So combining, the bathymetry as well. That's used for Earth modeling of all sorts. But I really wish I'd known that there was a version 1.1 sitting on your hard drive, but because we just released, but that's all right. That means we'll go back for more funding later. I was curious about the how you trained, where to or what input data sets you used for identifying where building corrections needed to be.
Yes. Let me go back there. It is in that table. Yeah, here we go. So it's kind of from travel times onwards. Now this is quite interesting because some people have tried to use OpenStreetMap building heights, which in theory would be a good idea, but it just hasn't got good quality global coverage. So we didn't use that at all. So we used a bunch of other ones to essentially, because we want to know the density. If you know kind of the density people, we can kind of infer that that'd be higher building heights and different information like that. So we used travel time. So this is a data set from Nelson et al. We used well pop constrained. We used some GHS urban database variables such as average greenness, built-up area per capita. We use the world settlement footprint, so that gives if it's building or not building. And then we also applied some filters to this to kind of create perturbations of what this could look like. Now I know that the group at DLR have kind of got a building height data set perhaps coming out, perhaps not. I'm not really privy to what's going on with that. That would obviously be the great thing to do. The other important thing to remember with using the predictor data sets is temporal consistency, right? So Copernicus DM is based on TandemX, which was flown 2011-2015. So essentially, we want information on trees and buildings from that period. So that's kind of what we had to be quite careful when we're selecting. Yeah. So it's kind of quite interesting. So when you're doing the flood models, you're essentially modeling on a landscape that was captured 10 years ago. I know landscapes don't really change all that much, but some places they do. So that's quite a difficult challenge actually, and all this kind of temporal consistency.
Okay, well, cool. I'll reach out to you over email, but we have been using it, and we've also been doing water masks using hydro lakes and some other data sets for at least for lakes, but which is also not perfect, but for our validation work. And so anyway,
so to go, thank you. So go back to the water mask. So we're essentially just resampling the Copernicus. So the Copernicus DEM has their own water mask, so we're essentially just using that as a water mask. Whether it's a perfect one remains to be seen, but it kind of works reasonably well for and it has good consistency with FABDEM, which is important.
Okay, thanks Mike for the question. While I wait for someone else to pop up with the next hand up, there was a question to you: how do we access to the list of FABDEM tiles that were corrected, the map you presented with the green tiles?
So we've corrected all of them. We've rerun all of it because we slightly changed the post-processing. So that means every tile will be different. It'll be a minuscule amount for the vast majority of them, but we have run rerun every single one. So every single tile will have some difference. However, if you want to know the ones that have the biggest difference, if you go on the Copernicus DM, it's got the website. They've got an Excel file of all the different tiles and when they've been updated and how they've been updated. So to go back to that map, the color represents different ways it's being corrected. I can't remember off the top of my head. Like sometimes it's ocean boundaries. That yellow, for instance, is basically they've just included the Norway LiDAR. Yes, there's a whole bunch of different ones. Yeah, I think Charles, don't you work on Canada, if I remember rightly? So as we can see, there's quite a few tiles up in Canada that's been
yeah, exactly
changed.
Yeah. So these green tiles are the ones with major issues corrected, but all of the tiles will be corrected and provided in the version 1.1, right?
1.2.
1.2.
Yeah.
Okay.
So version 1.1 is never going to see the light of day per se, because it just gets a bit confusing for everyone. So we're just gonna, but we kept it as 1.1 because it was sent out to a few different people. So we didn't want to publicly release a 1.1 and then the people who have received 1.1, the kind of the beta version, to be like, oh, hang on, which one do we use? So that's why we've called it 1.2, which is perhaps in hindsight it might get a bit confusing, but that's what we're going with. So yeah,
makes sense. Okay.
Thanks for the explanation. It reminds me on the versions we were releasing with CIAD and CIJA on SRTM void filter data products a couple of years ago. You seem to hit similar issues.
Yeah.
I was just smiling, because you had your 10 pixel boundary issue. Then the SRTM had a 1 pixel boundary issue where the incoming SRTM from NASA at the boundary, the pixel did not contain the same elevation information. And if you so one tile was different than the other one, and you needed to clip it to get it correct. So I mean, this is like you are always, if you're hitting this kind of large scale data sets, sometimes you really need to have attention to detail.
Yeah,
so
exactly.
Someone else wants to have the floor from around the world.
You have an additional suggestion, if it's possible.
Yep, go ahead.
Yes, for highlight artifact, I noticed that it's very useful to calculate curvature of the digital elevation model. And as soon you do curvature, even in a higher resolution, so at 90 meters, will show up immediately. So even a visual check of this curvature will, point out where are the artifacts in the underlying 30 meter. Because of course the 90 meter can be open easily and so on.
I think that's a really good suggestion. Thank you. That's that's really nice. Thank you for that. I've not looked into curvature actually. Thank you.
Yeah, this is the same question would have come from me. Usually, I don't show elevation differences or elevation, and for comparison, you do profile curvature. Slope is already an indication, but profile curvature really shows you the artifacts where people have messed up, where they have you see the border effects, where they have feathered, they have void filled, all these kind of effects where you have misregistration, all this kind of things.
Great. I'll add that to the quality checking now.
Okay. I had 2 questions to you, and I hope they are not too too dominant or pregnant here. Not too insisting. How do you ensure that you're not over smoothing your dam? I know you're working in the flood modeling, but how do you ensure that you are not doing it too smooth? And the second thing comes from the same related to that. Where would you not use your dam?
So the first question is that how do you not over smooth? I think, well, when we were developing that, I was quite keen to not over smooth it and really reduce the window sizes of the filters. I've kind of rein in the artifact. Other people thought differently. So I personally think it's not over smooth. Users might find differently. Yeah, it's very much a balancing act. Like we check so many different various image filters and different parameters for these filters. We didn't measure it per se. It was just kind of, okay, let's test it on a flood model. Let's see kind of what looks all right and kind of what visually looks sensible. Yeah, that's kind of what we did. I think quite an interesting, perhaps, view for developing DMs in the future is kind of release a product so up to stage 2 of our DM processing chain, and then kind of provide some scripts or whatnot for people to do all the post processing as they want, because some people might want a smoother DEM, some might want something else. So anyway, that could be something for other people in the future. And your second question, where wouldn't you use it? I wouldn't use it so in areas of steep slope and mountainous, really mountainous areas. So it really hasn't been designed to do that. And as part of the Demix project, which Peter Strobel might go into a bit in future coffee talks, it seems like FABDEM is not that strong in that sort of area. It's definitely it's strongest in your flat areas, your floodplains, with low slopes, and as you kind of increase the slopes, it's not so strong. Of course, what I would say for any application is don't just use one DEM. You don't just use FABDEM. Use Copernicus, use Merit, use whatever, because these other DEMs might be better. It's kind of quite difficult to know which one is likely to be the best, not which one will be the best. I think it's kind of key to remember. So I can't hear your hands, by the way.
I should unmute myself. I should learn. Apologies for everybody. Any other questions from the audience? Peter, Junko, Pyrong Ling. I see a couple of new names, old names here. Daniel, Tusa, Christopher, Andre, Kai Hao, Andrea, Vitek. The floor is yours. Vince.
Yeah, I'm testing some Zoom polls. Are you seeing the poll answers? You see the answers? Okay, sounds good.
Yes, this is something which you all can please fill in the floor. And you're all our guinea pigs today, and we are really grateful that you're all attending and that Laurence is presenting today. Any other questions? Otherwise, I have just one more. Where did you process all the FABDEM? Locally on your machine?
No. Yeah, we used an HPC, and yeah, we used some GPUs as well. Yeah, so it's a big old processing amount, and it certainly wasn't a local machine job. So yeah, unfortunately, when you're working at this sort of level, yeah, you need HPCs.
Okay. Super. Thank you. If there is someone else wants to have the floor, please raise your hand or unmute yourself so I can give you the floor.
And if you're a bit shy to ask a question here, contact me afterwards. Obviously, it's better to do it now whilst I'm speaking. But yeah, if something comes to your mind tomorrow after you've had a nap or whatever, you can yeah, please do email me.
Tusa Sethi has a question for you. Please, floor
Hi.
is yours.
Laurence, thank you, Hannes. Laurence, beyond flood modeling, have you seen any interest in other applications with this?
Yeah. So, well, I guess kind of related is storm surge. I had group work on health site accessibility, which is quite interesting, and where to locate evacuation sites. Someone was looking at was it like deforestation, or basically planning routes for cutting down trees. I guess accessibility as well for vehicles for that. Yeah, so that's kind of some applications I know of is being explored, but you know, it's probably just the tip of the iceberg, really. But it's really interesting because I kind of thought, just like flood modeling, whatnot. There's quite a lot of different ones.
Fair enough. No, for all of these, the license has been procured from FABDEM, is it? These academic projects.
Yeah, quite a lot of them are academic, and I think where it's like a humanitarian sort of action, I think it's a bit of a fuzzy line there. Like, I would always say, when in doubt, go to FABDEM, and I should have probably put the email link on here. But yeah, like if you're doing it for like humanitarian, I would probably say that's okay. But yeah, I don't want to formally say yeah, it'd definitely be okay.
No problem.
But basically, they want to avoid a big consultancy doing flood maps based on FABDEM because it's their market advantage, right? So that's kind of what the application they want to avoid.
Okay, super, thanks. Anyone else wants to have the floor? If this is not the case, Vincent, is there anything other polls which you want to schedule for today? I have seen the second one now. So we have seen the coffee talks and the uses. With that one, well, let's all give our presenter from today first a big clap. A virtual and a real one. Thank you for being here with us today. Laurence, it was really interesting what you have presented today. I think this sets standards high for the people to come. I think the next one is John Lindsay with white box tools. So I mean, we try to have quite a variety with his coffee talks, coming from what we already started a couple of years ago, Tom Hanger and myself, where we were editing the book. We try to have the combination between digital elevation models, software, and applications. So we're trying to do that also here with the coffee talks to have the variety. If I want to summarize a little bit what we have seen today, you have presented us the methods, how you generated the first terrain map at 30-meter resolution using artificial intelligence. With a variety of underlying auxiliary informations, like for buildings and trees, using random forest, so where you used 15 forest parameters and 14 urban parameters if you have seed, and you have further developed it against 12 LiDAR depths. What we learned as a maybe interesting point for everyone to use, that there is a license and a price if you need to use it for commercial usage. So it's not as free as Copernicus, but I mean, this is fine. And you have really nicely shown us all the kinds of issues which one discovers as a processor of digital elevation models and the various cycles you have to go through if you correct that. Welcome to the world, I can say so. Being there postdoc a couple of years ago, I'm I'm looking forward to your further career, to say so, to see what we see further on. What I heard today is that we will have the next public release for 1.2 in October 2022, or maybe in the beginning of November. And as an output from that one, from your products is mainly used in flood modeling, but also in other kind of accessibility things. And one of the big outcomes there is the global river topology dataset GRID, which contains B4 occupations. And I think that's a really interesting thing, which is an outcome from your work here. Yeah, in general, I think we learned today from your comments that your FABDEM is fabulous for flood modeling in low slope areas and flat areas, and not maybe in mountain areas. At least this is, you communicated well to us. And what else should I phrase here back? Yeah, you got some comments about what you can improve, what you can work further on, being it profile curvature, being it over smoothing. But I think that's I think this is the exchange which we want to facilitate, and hopefully we were inclusive to you, we were nice to you, asking our questions, and this is what we want to encourage people here in this kind of community, that it's an open exchange where everybody can have the floor, can come in and ask questions, feel acknowledged, is not shy to ask questions. I mean, there's no dumb questions, there's only stupid answers which we can give, so we need to also work on that one. We wanted to also give you the possibility in a Google form to give feedback to all of us, to us as a board. You see a couple of the board members from the Geomorphometry here with me, Peter Good, Carlos Groman, Vincent, Recurs, I don't know if more from the board is here. No, that's for the moment here. I think Peter, we will sort it out. Sorry, I cannot do that now while talking here. Maybe we send it afterwards via the emails which we have received via the radio station, if we do not manage now, that you can fill in the form. So with that one, I think we are at, I head over to Vincent. Sorry, I see you have raised your hand. I hope I have not anything what I need to ask you. Yeah, correct.
Yeah, I just want to say we welcome input or recommendations or volunteers for these coffee talks. So we have 4 scheduled right now, but we want to keep that going up until the next conference and then after the conference. So if you have something cool to share with the community, feel free to email us, or if you want to hear someone speak, you can also send us recommendations.
Exactly. So for example, thanks Vince on that one. I mean, maybe everybody opens up the camera so we can make a screenshot from that one for further promotions. If you would be also kind and open up your camera for that one, that would be really appreciated. And we have internal discussion if we should do it every 2 years or every year, every month or every 2 months. And this depends on you. You know, this is an inclusive event. This is your event where you can speak and talk with us and can speak to the community in the world, present what you're doing. And if this is working for you, then we can also do it every month. But I mean, that depends on all of us coming here together. With that one, Vincent, are you taking the screenshot or who's taking the, sorry, I'm talking too much here today. I can try to make also the screen. Is the rest of the persons here coming on? Junko, Yin, Si-Yun, here are you. Maybe we have the last 3. Yes. Hello, Junko. Long time not seeing you. So yes, Vincent, and the last one, please. Then we have a full screen.
All right, I'm gonna go in Just got to figure my thing out here. Okay, I'm going to go in 3, 2, 1. Did it do it?
Yes,
okay.
3, 2, 1. Everybody smile. Okay. So with that one, I thank you everyone for attending today. We see each other in 2 months' time from now. Same time, apologize for some of the early birds in the video conference or the late birds. We know we try to find a time slot which fits everyone. We know this is we want to be around the world inclusive, which is not always easy. We know, but I mean that's the way we can make it. Okay, with that one, everybody, thank you for attending, and maybe the board can still stay for a couple of minutes here in the Zoom call. Thank you, everybody. Enjoy the rest of the day.